So we'll be discussing on this, right? So as already mentioned previously that when talking about sequences, we keep learning about the different patterns, right? How a particular number is arranged, how if I get, a range of numbers, say maybe 2, 5, 8 and all, how do we find a relationship between those numbers? So,
Mm.
keeping that previous concept in mind, we'll be trying to solve one of the most popular questions that has been repeated quite a number of times in the past papers on a similar lines. Okay. So, if I just
Okay.
zoom in a little, this is one of the questions that carries a total weight of 30 marks in your paper. Okay. And we'll be trying to see how we can easily decode it. So, if we look at the first thing, it says that we have to fill in the missing values, right? So if I
Mm.
just show you the pattern, you can see that there is a relationship that we need to find out between the stage and the longer base of a trapezium. For
Mm.
solving this, be clear, you need not know much about what is the figure of a trapezium. That details is not required to solve this question. Only thing we have to correlate is the number. So if I see when n equals to 1, my L equals to 4, right? The very next step, when I make
Mm.
n equals to 2, my L becomes 6. In the third step, n is 3, L is 8. So the only thing that I can visualize very easily, nothing, no other concepts required. Just see, when I increase n by 1, my L is increasing by plus 2, right? And that is something I can verify. You see, when it's 3, L became 6 plus 2, 8. When n became 4, L became 8 plus 2, 10, right? So now they have asked me, I have to fill it up, right? So it was 4 and 10. So when it is 5, I obviously know I will have to add up 2 here. So my corresponding value becomes 12, right? Again, I am increasing this by 6. So 5 plus 1 is 6. Now my relation will become 12 plus 2, that is 14. Is it clear? So we see
Yes,
that
ma'am.
as n keeps increasing by 1, my value of L becomes plus 2. One
Mm.
thing to remember here is that the most common mistake that we make is that we say that with increase of n by 1, the value of L doubles. It is not double, it is just addition of 2 with the previous number. Okay. So
Mm.
taking this concept in mind, now they have asked me to define two patterns for L. Okay. So when I talk of patterns, I will have to see what is the type of relation that I have got. Okay. So I could see whenever n is increasing, my L is also increasing, right? So I can say that one of the patterns that I get to learn, that is an additive pattern. Why? Because in additive pattern, we see that in all the columns that we come across, not only columns, it can be different sequences that we come across. Every next number has something added to it. So here for n, I can say it's following the pattern of n, n plus 1, n plus 2, like this, right? Where my n started from 1. Similarly, for my L, I can say L is following L, L plus 2, L plus 4, like this. Correct? Because at every step 2 is added. So first pattern that I can see, that's an additive pattern where N increases by 1 and my L increases by 2. Correct? Is this clear? The
Yes,
first one
ma'am.
is very simple. For the next one, I will first try to figure out this part, okay? And then I'll get the pattern. That's the only way we can get it easily. So it says we have to write down a general rule for L in terms of N. So what is the thing that I saw? Whenever N increases by 1, L will increase by 2. So it is obvious that if I want to find it out that way, I can simply use this formula. L is 2 times N plus 2, because as and when we increase, L is nothing but 2n plus 2. So from this, my second pattern that I can very well use, that's called the formulaic pattern. Okay. Because here I will be using a set relation, a set equation to find out my values. Clear? Here, I did
Yes,
not make use of an equation. Here, it's an equation-based thing. So from there, I got my relation that L is 2n plus 2. Now let me verify it for a few things. Let's see. When n equals to 1, what is L? L becomes 2 into 1 plus 2. You see, that is equals to 4. Here I got 4. Same thing if I verify with L equals to when n is 2. So I can write L is 2 times 2 plus 2. That becomes 6. So is my relationship varied? Yes, it's verified. That 1 corresponds to 4, 2 corresponds to 6. Right? That is where your question comes. Am I clear with this part?
yes, ma'am.
Yeah. So coming to the next part of this question, if we just get hold, the next part just asks you, I'll just quickly get you the next question. So for the next part, we have to verify the general rule and also go to a similar kind of pattern. So here's my next part of this question. Now for verification, we have already done with one or two numbers. I can do with a random number as well. Okay, let me take n equals to 3. I wrote my rule as L is 2n plus 2. If I just substitute n as 3, I get as 2 times 3 plus 2. That is 8. This is verified. You can do with any other number rather than taking n as only 1, 2, 3, 4. You can go for any number. Take n as big as 7, 8, 9. You will always get the corresponding relation. Clear? So sequences can be pretty easy if we just follow the numbers. Now coming to a similar sort of table, okay? Here again, the subparts are very similar to what we have done earlier. So let's try to apply that knowledge that we just learned. If you see here, again, they have given you a set of n values, which ranges from 1 to 6. And they have given you the longer base of the trapezium, the smaller base of the trapezium, the height and the area. Okay. So you have to predict more values and record these and describe in one word one pattern for column A. This is very important. Let us start with this. That will only help us to give your corresponding values. If you see, let me keep a focus on this and this. You can see that all my numbers in the column A, that's what area, all these happen to be perfect squares, right?
Yes.
9, 25, 49, 81. And one more thing, if I see, 3 squares up to 9. 5 square is 25. 7 square is 49. 9 square is 81. So, can I drive a general relation? Yes. I can see if I just square the height, I'll get my corresponding area. Isn't it? So here, anytime that I'm squaring my height, I'm getting the area. So if my area is represented by A, I can simply write the formula as A equals to 8 square. Correct? So this is my basic term that is there. Now I can test it for anything. For testing, I can take any one value. 7 square is 49. Now they have asked me to fill up the table, right? For filling up the table, what do I need to know? Very easy. You first see the height is increasing by 2 at every level, isn't it? 3 plus 2, 5. 5 plus 2, 7. 7 plus 2, 9, right? So what will be the next two terms? They will be 11 and
13.
13. So what will be the corresponding area values? 121
121.
and
169.
169. Perfect. Can we come for anything of the longer base? Can you predict anything with the longer base part? That you can see any
Yeah.
particular pattern that you can see here?
They are also in the pattern of 2. We have
They
to
are also
add
in
the
the
2.
pattern of 2. Correct. So if I take the next number, what will this next number be after 10? This shall
12.
be 12 and this shall be 14, right? Because everything is increasing by 2. What about this one? The
Same, the
smaller
pattern
base?
of
It's the same thing. It's also increasing by 2, right? So I get a 10 here and a 12 here. So even without knowing the previous terms, I can just predict, right? Here we did not use. Could you tell me based on the concept we learned, did we use an additive pattern here or a formulaic pattern here?
Additive pattern.
Okay. So for the longer and the smaller, we used an additive pattern. But with respect to height and area, we have used a formulaic pattern,
Formula.
right? So that
Yeah.
completes our table. So this happens to be one of the most important questions that are there. So I hope you can refer to this and practice more on that. Right?
Yes.